Hello, welcome back to examples of interior and exterior angles. So if you will make sure that you get something to write with, grab your notebook, interior and exterior angles of polygons. Alright, so the formulas that we talked about in the last video, we didn't write down. So let's go ahead and write those. We have sum of the interior. These are all on the inside, and we said that was n minus 2 times 180. We said one interior. Other words that you will see for one are each or an. So it might say if each angle, interior angle, or if an interior angle, one interior angle, all of those three mean the same thing. Okay, so we're going to take n minus 2 times 180 and we are going to divide it by n. n minus 2 times 180 divided by n. Remember, n is the number of sides on our shape. N is the number of sides that the shape has, a polygon. Okay, then we have the exterior, so we have the sum of the exterior, which is always 360. Notice it doesn't have a variable, so it does not ever change. And then we have one exterior, which is 360 divided by n. Okay, and again, one, each, and any of those things, they're all the same. Okay, so those are our formulas. Now we're going to do some examples to go through that. Pause, rewind if I move too quick, okay? All right, so on number one, now on your problems that you get, that you see, like on a worksheet or on the Google Forms page, the problem is going to all be written out in words. So for right now, I don't want to write all of those words out, so I'm just going to kind of abbreviate information that we're given. So for number one, we're going to be given this question. It says, what is the sum of the interior angles of a pentagon? Okay, what is the sum of the interior angles of a pentagon? Okay, so this has a couple different things that we need to understand. Okay, first of all, this is important. We are not doing one, we are doing sum. And then it also tells us whether we're looking at interior or exterior. So for this problem, we're going to go to our formula for sum of the interior, and I'm going to write this whole thing down, not just the right side. I'm going to write all of it. Okay, and the reason that that's going to be important, I'm actually going to abbreviate a little bit more. S for sum, and then I'm going to put the int down here at the bottom. So sum of the interior equals n minus 2 times 180. The reason that this is important is because eventually we're going to be given this sum, and they're going to ask us to work backwards to solve for the number of sides. Okay, so as long as we continue to put that in there, it won't freak us out when we get to that point. Okay, the other thing that this tells us is that our shape is a pentagon. So for a pentagon, how many sides will that have? I didn't hear your answer. Say it again. 5. Thank you. Penta is 5. So here we're going to rewrite this formula, and we're going to change the n to a 5. So we're going to have 5 minus 2 times 180. Okay, and then all of this stuff is over here on the left side of our, or not left, the right side. So we're going to do parenthesis 5 minus 2, and then multiply that by 180, and we get 540 degrees. So the sum for this problem, or for any pentagon, is 540 degrees. Okay, if you don't have a calculator that has the parentheses, you can turn it sideways and it should still be there. Or you could do 5 minus 2 in your head because you're smart like that, and you could just do 5 minus 2 is 3. 3 times 180 gives us 540. Okay, but make sure you are using a calculator of some sort. All right, number 2 says, what is the sum of the interior angles of a 27-gon? Okay, so that looks kind of weird, 27-gon. There's not really a name for that. All that's telling us is that n, the number of sides, is whatever that number is there. Okay, so we want the sum of the interior for a 27-sided shape. So we're going to use this same formula. sum of the interior equals n minus 2 times 180. We're going to put a 27 where the n is, bring everything else down. 27 minus 2 times 180. So 27 minus 2 is 25. 25 times 180 gives us 4,500. 4,500 degrees. Now notice that that's a much bigger number than what we got before. So as the number of sides increases, then the measure of those interior angles, that sum, is going to increase as well, and it's just going to kind of keep getting bigger and bigger. So don't panic, don't freak out if you see this, what we call a big number. Okay? All right, I'm going to squeeze one more down here before I turn the page. What is the measure of each interior angle of a regular octagon? Each interior angle of a regular octagon. Okay, so again, this word is important. Each, and then interior. So with that, I'm going to go up to the top and I'm going to grab my formula for each interior. Each is right here, each meaning 1. Interior, n minus 2 times 180 divided by n. So I'm going to write this formula down at the bottom. Each interior equals n minus 2 times 180 divided by n. Okay? And right here, where I see these n's, this is my variable. Variable means the thing that changes. So for this problem, I'm going to change that n to the number of sides on a regular octagon. Octa means 8. So I'm going to rewrite this equation, and instead of the n, I'm going to put an 8, both places where we see that n. Like that. So on my calculator, I'm going to do 8 minus 2 in my head, so that is 6. 6 times 180. I'm going to go ahead and hit enter so that I get the sum, or not the sum, but the product of that, the answer for all that stuff up on the top. And then we're going to divide it by 8 on the bottom, and that gives us 135. So each interior angle for a regular octagon is 135 degrees. Okay, just a little bit of a side note here. If you're doing each interior or each exterior, one interior, one exterior, that number that you get can never be bigger than 180. Well, it can't even be 180 because 180 would be a straight line. In order to be an interior-exterior angle, it has to have a little bit of a bend to it. So it's going to be less than 180. So if you ever get a number bigger than 180, that's your red flag that, whoops, I did something wrong. Okay, and we can fix it. All right, so let's do some more. I want to get into, let's see. Actually, you know what? I don't think we need to do another one of those. Let's look at this. Let's say that the sum of the interior angle of a polygon is 1,620 degrees. Like, we're told that. The sum of the interior angles of a polygon is 1,620 degrees. How many sides does that polygon have? How many sides? Okay, so this case, we are solving for n. N is going to be our question mark. That's what we're trying to find. And this 1,620 is not going to go for n. We do not have 1,620 sides on our shape. This represents the sum of the interior. So that's going to be S, the interior angles for our problem. This is going to be S. Okay, so we're going to go to our formula for sum of the interior. So that's this one. Sum of the interior equals n minus 2 times 180. So I'm going to write that on my paper. Sum of the interior equals n minus 2 times 180. And we said we're trying to figure out what n is, and we're going to replace S, the sum way over here, with the 1620. So 1620 equals n minus 2 times 180. All right, something. So y'all can use an equation solver if you feel like you need to use that. Type this into whatever that equation solver is. I'll go through the steps real quick. If I want to get n by itself, we're going to divide off by this 180 first. That's going to make that go away. 1620 divided by 180 leaves us with 9. So 9 equals n minus 2. That's an n, not an h. Okay. So again, this becomes our equation that we're solving. 9 equals what number? Minus 2. The opposite of minus 2 is add 2. So n is going to be 11. N is 11. So an 11-sided figure, if we plug 11 back into this equation, 11 minus 2 times 180, that would give us 1,620 for the sum of that. Okay? All right, so a little bit of working backwards. Don't panic. Just use your formula. Practice. If y'all need help, remember you can come and find me at the Zoom in our meeting room, or you can find me at Remind. You can find me. Most of your parents have my cell number by now. Okay? Make sure you're finding me somehow. All right, number 5. On this problem, it asks us to find the sum of the exterior angles of a nonagon. Sum of the exterior of a nonagon. Okay, so again, this tells me a couple different things. Tells me sum exterior, so that's going to tell us which formula we're using. And this nonagon tells me that n is how many? Non is 9. 9. Okay, so I'm going to look back at my formula for sum of the exterior. I see sum exterior right here equals 360. So sum S exterior, sum exterior equals 360. Y'all tell me, where's this 9 going to go? N is 9. Do you see an N in here anywhere? No. This is the answer. We're done. The sum of the exterior angles of any polygon. Doesn't matter how many sides it has. It could have 9 sides. It could have 5,822 sides. The sum of the exterior angles is always 360. It will never change. So that is your answer, and you get to move on. Okay. Quickly. All right. What if on this problem it is asking us to find each exterior angle of a regular 20gon? Each exterior angle of a regular nonagon. Okay, or instead of each, it might say an exterior angle. We actually see that a lot in the problem. So an exterior angle of a regular 20gon. Okay, an means 1. So 1 exterior, and this 20 is going to be our n, right? Number of sides, 20. So I'm going to find my formula for 1 exterior. 1 exterior is this, 360 over n. Okay, so 1 exterior equals 360 over n. In this problem, we have this 20, which we said is n, so we're going to put it right here, and we're going to have something equals 360 over 20. 360 divided by 20 will give us our answer of 18. 18 degrees. And again, all of these are angles, so as we work through those, our answers are all going to be in degrees. Okay, if we're solving for n, that's going to be the number of sides. Okay, all right, one last one. I think I have enough room to squish it down here in the bottom. All right, one last one. All right, on this we have the exterior angle of a regular polygon is 9 degrees. How many sides does the polygon have? Okay. So the key words that I see, the exterior. How many is that? Is that all of them together? The exterior angle. That is 1, right? So I have one exterior angle that is 9 degrees. So this is going to go for our one exterior. That's our one exterior angle. How many sides? So we're solving for n, figuring out n. So I'm going to write down my formula for one exterior. It says 1 exterior equals 360 over n. So we're solving for n. So we don't know what this is yet. We don't put the 9 there because the 9 is not the number of sides. 9 is our angle. It's going to go over here for this one exterior. So this is going to say 9 equals 360 divided by some number. Okay? So here we're going to do a real quick little cross multiply. Put 9 over 1. 9 times n equals 1 times 360, a little butterfly method, right? 9 times n, or the opposite of divide is multiply, so multiply that n over to the other side. And then we want to get rid of the number in front of n, divide by 9, n equals 360 divided by 9, 40. Okay, I will give you a little hint right here at this point. Division, I don't know how that got there. Okay, division is just like multiplication, right? I want to know 9 times what number makes n. So if you just do 360 divided by this 9, it'll get you the 40 as well. 360 divided by 9 is 40. 360 divided by 40 is 9. That's your fact family that we've done so many times before. Okay? All right, use the formula. Make sure you're writing down the correct formula. Plug the numbers in. And if you need the list of shapes, the names of all the shapes from the other video, you might want to go back and write that down before you get started on the assignment. Okay? All right. Love you. Bye.